because they're the most important. Where we're eventually headed here is that we want to look at proving that triangles are congruent. So I'm going to tell you certain bits of information, and you'll need to prove to me that the triangles are congruent. So we're going to talk about different ways to do that today, what pairs of sides and angles and what combinations you need. But this list is looking at ways to get those sides or angles, because I won't always tell you, oh, these angles are congruent. I might tell you something about the angles that should lead you to the conclusion that they're congruent. And you're going to have to make that logical step. So for example, I might tell you that I have an angle bisector. And so you'll have to connect the dots to say angle bisector, oh, that means the angle's split into two equal pieces. It's split in half, so that means the pieces are the same. And now I have congruent angles. So I've gone from bisector to congruent angles. The other big ones that I've talked about, vertical angles. You should remember vertical angles are, here's the intersecting lines and these two angles across from each other. They're congruent. So that's a visual thing in the diagram, is if you see those type of angles in the diagram, they're vertical angles. Perpendicular lines. The nice thing about perpendicular lines is that they make right angles. And right angles are always congruent. The symbol that you'll see for perpendicular is this symbol right here. It'll be where our congruent symbol usually is. So if you see this written out, then that is telling you perpendicular, which tells me right angles, which tells me congruent. So those are kind of the logical steps that you'll have to make. We're working towards that, but we're not quite there yet. But let me have you write down the sides. The pieces that we have for sides is midpoint and bisector. Again, those are similar ideas, splitting the segment into two equal pieces. And then we have reflexive property, which remember said that something was equal to itself, like A equals A. And so we'll use that to show when we have a side that's in common. All right. I said yesterday that usually we need 6 pieces of information to prove triangles are congruent. We need 3 pairs of sides and 3 pairs of angles. But what we're going to look at today is that we can actually use different combinations of those, and then we only need 3 pieces of information to prove that the triangles are congruent. So we're going to look at different combinations of those. The things you want to write down on each slide here are the congruence postulates. So this one you're going to write side, side, side. And you're going to put SSS in abbreviation in parentheses because that's how we're going to abbreviate it. And then I think, so there should be a blank, the first, like 5 groups of blanks. So the first blank you're going to put side, 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 or SSS. And then it says must have. After must have, you're going to put whatever's in blue over here. This is the information you need to know in order to prove side, side, side. So what this says is that if I have 3 pairs of sides being congruent, so if I have 3 pairs of sides in one triangle, congruent to 3 pairs of sides in the other triangle, then the triangles are going to be congruent. That means that if I know the 3 pairs of sides, I don't need to know anything about the angles. That's enough information to say the triangles are congruent. So as soon as I have my 3 pairs of sides locked in, I can say triangles are congruent by side, side, side. And we're going to have 5 of these in total. But if I have that combination of information, then I know the triangles are congruent. Next one is side angle side. So again, on the left, you're going to write side angle side or SAS, and then it says must have. This is what you're writing for must have in blue. Side angle side means we have two pairs of sides and then the pair of angles that's included in between them. Two pairs of sides and the pair of angles that's included in between them. Here's what I mean by that. Is I've got these two pairs of sides. So here's my two sides on this triangle. And then I can look for what's the angle included in between them. Another way to look at it is like, what angle did I just make? Well, I went from S to R, there's the vertex, to T. So the angle that I just formed that's in between the two sides is this angle right here. Even clearer if I just take away the diagram. So I draw out the two sides, and I'm looking for which angle I want. Well, the angle that I just made, the angle that I want, would be this angle right here. So that can help me see which angle is the included angle. But it has to be the angle that's included. It can't be the angle like up here or over here. That's not the angle that's included between them. So I want the two sides and the angle included in between them. That's side angle side. Then I could also have the same idea in reverse. There we go. Next, we have angle side angle, which is the same idea, just flipped around. So we had side angle side, SAS. Now we have ASA. This is the two angles and the side that's included between them. So again, if I look for the two angles, here are my two angles. And then I could take away the diagram and I could see that the side included in between them is this side right here. The side that's in between those two angles. Another way that you can see it is if I kind of go around the diagram and see the tick marks that I made. I have the angle first, then the side, then the angle. Versus my next one, watch before you write down, which is angle, then my side. Angle, angle, side. Now you can start writing. So angle, angle, side needs two angles and the non-included side. Two angles and the side that's not included between them. So here's my two angles. And then here is my side over here that's not included. Again, clearer if I take away the picture. This side that I marked congruent, this side is not in between the two angles that I made. So that just has a different name. It's a visual thing in the diagram when I talk about included versus not included. So we'll have one more, and it's a little bit different. So far, I've got side, 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 all three sides. I've got the two sides and the angle included. I got two angles on the side included. I got two angles on the side that's not included. This last one's a little bit different. The last one is just about right triangles. And so in a right triangle, I have still three sides, but we split off the sides to talk about the side that is across from the right angle, the longest side in the triangle. That is called the hypotenuse. Hopefully you've seen these terms before maybe when you talked about Pythagorean theorem. So the hypotenuse is this longest side across from the right angle. And then the two sides that build the right angle are the legs. So each of these sides are a leg. So this side across from the right angle, hypotenuse. These other two sides that build the right angle are the leg. So in that right triangle, if I've got the hypotenuse and if I've got one of the legs, then that's enough information to prove the triangle's congruent. Now, just like all the others, this is still 3 pieces of information. Because in order for this to work, I need to know that it's a right triangle. This only works in right triangles. So I still need 3 pieces of information, just like the others. Side, 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 angle, side, angle, side, angle, 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 side. And then for hypotenuse leg, I need right triangle. So what do we need? Hypotenuse, leg, right triangle. So these are quite a few of these. I just want to focus in. We'll start with just focusing in on side, side, side. And seeing how we track and look through side, side, side to prove the triangle's congruent. Decide whether the congruence statement is true. Explain your reasoning. So we can go through, actually look at the congruence statement. Because what I said yesterday is in the congruence statement should tell you which pieces match and go together. So I can look and see that AC, first 2 letters, should match up with first 2 letters CA. Let's see, AC is 9. And then CA, oh, well, I just drew the same side again. This is reflexive property. When we get there later this week, this is going to be reflexive property. When I have a side that is shared between these 2 triangles. So that is reflexive property. Then I could keep looking at my last 2, CB and AD. So I have CB is 7, AD is 7. Those the same? Yeah, good so far. Then my last pair of sides would be first and last, A to B, and then first and last, C to D. A to B is 3, and then C to D is 4. Oh man, it's all ruined. Because those aren't the same. One of them is 3 and the other is 4. So are these congruent? Nope. They aren't. And we're asked to explain, and the reason these aren't congruent is because segment A to B and segment C to D are not congruent. So I'm missing a pair of sides measuring the same. Next one. I'm going to go quicker this time. I'm going to match up my 3 sides. D to F, first 2 letters. And H to J, first 2 letters. There's my first pair of sides. They have the same tick marks, so they're congruent. Then last 2 letters F to G and last 2 letters J to K. So that is these sides. Those are marked the same, so we're good there. And then D to G and H to K. So I got my tick marks all lining up in the way that the congruence statement says they should. So that means Now that I've got my three sides, I can say, yes, these triangles are congruent by side, side, side. And last one, I also have my three pairs of sides lining up in the same way. Here's one pair of tick marks, here's two pair of tick marks, here's three pair of tick marks. So I've got side, side, side again. But the answer here is no. The congruence statement is not true. So I want to give you a minute and see if you can pick out what's wrong. The problem is here. Because this would say, remember, I want my sides to match up. P to T, last two letters, should go with last two letters R to T. Here's P to T. And on the other triangle, here's R to T. Nope. Those two sides don't go together. So the congruence statement, these triangles are congruent, but our congruence statement is wrong. So it should be, if I want to use QPT, sorry, cross off this whole thing. QPT, in this case, Q in this triangle should go with which point in the other triangle? It should flip around and go with R. Q lines up with R in this triangle. And then P on the top here should go with, on the top over here, S. And then T is going to go with itself. So the triangles are congruent, we just wrote the statement incorrectly. By the way, if we're thinking about transformations from last week, this is a translation. It got shifted. And then this is a reflection. The triangle got flipped. Come over there. Questions on any of those? All right. Next group of problems. State the third congruence that must be given to prove that JRM is congruent to DFB. Using the indicated postulate. So here's what we're doing here. In each problem, we're using this same set of triangles. So we're going to mark up this triangle a bunch of different times. But what I'm trying to say is that each of these postulates would need three pieces of information for you to tell me the triangles are congruent. So I'm telling you two of them, give me the third. That's the idea. So let's say I wanted to use side, side, side. What I like to do a lot of the time is I like to write whatever I'm using, and then when I've proven one, cross it off. So first off, I am told J to R and D to F. So I have J to R and D to F. Oh, that's my first side. So remember, I need three pairs of sides in total. So I'm telling you two, which one's the third? Then I have J to M and D to B. J to M, congruent to D to B. There's another pair of sides. So in order to get side, 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 well, I have side and I have side, so now I just need another side. So I need to write out what that third side would be. It would be this side right here. So it should be R to M and F to B. And if I knew that third pair of sides, then I could wrap it up and say side, side, side. Those are congruent. So this would be the third piece of information I need. All right, same diagram, same information. Right, it's the exact same two pieces of information. But this time I'm using side angle side. So I'm going to mark off the same pieces of information. I've got J to R and D to F marked congruent. So that's a side. And then I have J to M and D to B marked congruent. And so that's another side. So in side angle side, I've got a side, I've got a side, I need an angle. Right? That's the third piece of information I need to use side angle side. So what is the angle I need? Well, the angle I need should be the included angle between these two sides. So here's my two sides. Which angle's included between them? Well, the angle that I just traced out was this angle right here, angle J. And I want angle J to match up with which angle is included in the other triangle. I trace it out. What angle did I just make? Oh, I made this angle right here. Angle D. So that would be my third thing that I need to prove this triangle's congruent. Last one. We'll mark up this diagram one more time. This time we want to use hypotenuse leg. And remember I had said with hypotenuse leg, I still want three things. I want hypotenuse, I want leg, and then hypotenuse leg only works with right triangles, so I need a right triangle. I need a right triangle. So let's see what we've got. We've got R to M and F to B, so we have a pair of sides here. We'll figure out which pair of sides that is in a second. Then I have angle J is a right angle, and angle J is congruent to angle D. So angle J is a right angle, so I'm going to make a box. Show it's a right angle. And then it says angle J is congruent to angle D. Oh, that means that this is also a right angle. Since they're congruent, they got to measure the same. So they're both right angles. So that tells me right triangle. Then if I look at the right angle, the side I was told is the side that's across from that right angle. So this longer side that's across from the right angle. And so that is the hypotenuse. That side is called the hypotenuse. So this is telling me the hypotenuse. So I've got the hypotenuse. I know it's the right triangle, so the information I'm missing is the leg. So the leg are the two sides that build the right triangle, so I can use either of the sides. So I'll just pick one. Let's pick these two. So R to J and F to D. All right. Take the last few minutes. The next group of 3 problems at the bottom of the page. You're going to do the exact same thing we just did. I want you to try those 3 on your own. If you have questions, let me know.